Probably one of the best parts of working from home, and there's not that many, is that currently teaching this stuff, our linear relations with graphs, equations, gradients, intercepts, is not having to hear you guys in class say, "Oh, you don't use this stuff in real life," because you do. The only problem, I guess you guys are having is actually seeing how it's used in real life, because a lot of this stuff you do without realizing. So what we're doing today is we're doing word questions with all the stuff we've learnt. Mainly we're making equations and then putting numbers into them. Hopefully by doing that you'll see that real life situations do often pop up with straight line graphs, and you do have to know the maths around them. It's just that in real life you're not asked to usually make equations out of it. We're being a bit more formal, a bit more mathematical than what you'd usually be used to, but um, they're a real life thing. So let's do a few of these real life word life questions. Mathematically, what we'll require from you is to remember that this is the way we like our equations set up. There's usually the letter y out the front. We might turn that letter into something else today, depending on what we're measuring, what real life thing we're actually trying to solve. We put a letter out the front. We have an equal sign, and then we have mx plus c. So we have something timesing something else, and then something else being added onto it. So these are our letters. And then the M and the C, as we should have learnt in a previous lesson, if we were at school, they represent parts of our graph. Um, so the M, there's going to be a number here, right? So we're going to be turning this into a number. So the main thing you guys will have to do in today's lesson is turn this into a number. So there's going to be a number right here. There's going to be a number here as well. The ones I put in red are going to be numbers. And this number represents the gradient. And that's just how fast your graph goes up. All right, so you can think of it as a regular kind of going up amount, if that helps, right? It goes up and then it goes up some more and then up some more as well. It's a number that you'll be looking for in today's problems that keeps happening over and over again. There's going to be another number. It's going to be going here. And this is going to be kind of a starting number. This is usually the y-intercept. So it's going to be a number. It's going to be the y-intercept of your graph. Not that we'll actually graph them today. And we'll view this as our starting amount. So you're going to be given a word question today. You're going to have to start with an amount. You're going to put that number right here. All right, so you're just going to set things out exactly like this, with the equal sign exactly there, the plus sign exactly there, then a couple of numbers here. So this is the number that you'll be starting at, and then this is what it goes up by. So to help you guys make sense of that, even though we've looked at it a few times over the last week, we have this non-real life real thing rule where y equals 3x plus 2. We should be trying to look at it and to see this 2 and to say my graph starts at 2. Right, so if you were actually graphing it, you'd put a point at 2. Incidentally, in a table of values, this is also turning x into a 0, gives you a 2. Right, it's basically saying start at 2. And then this 3, what this 3 is telling you to do is just to count up by 3s. So what it means is when I step across one step, my graph should be 3 points higher than it was before. So put another point here. I've gone across 1, and I was at 2, but now I'm up at 5, because I'm just counting up by 3s. That's what that 3 tells me to do. It's my gradient. It says go up by 3s. All right, so then my next point would be up at 8. My next point's at 11, and my next is at 14. All right, so this point would be at 11. This would be at 14. All right, that's what those two numbers always tell me to do. And I think understanding that is really helpful, right? This 3 says go up by 3s, and the 2 said, well, you should start at 2, right? And those two things come together to make an equation, to make a straight line rule that we can graph and that we can work with, right? Counting up by 3s, but starting at 2. All right, and this slide is here just in case you want something for your glossary. This is for our word problems. We're going to be putting it into this format, the y equals mx plus c format. So numbers go here, letters go there. All right, and the number that goes here will be our gradient. So we're going to be looking for a steady rate of change, something that happens over and over and over again and makes our numbers go up and up and up. You'll see what we mean soon when we do our first example. And the number we put here is kind of a constant is the way you can think of it. It's going to happen no matter what. It's going to be the number that you put in at the start before you start counting up by whatever this number is. All right, so in a second, we're going to give you a few examples of what we're asking you to do today, which is really just having a template and putting some different letters and different numbers into them. But what we really want you to do is try and think about what your variables are. And what that means is what are the two things that you're measuring or comparing. For the most part, it's going to be money, and money is going to be changing over time. Right? As time goes on, things cost money. You want to identify your starting amount, as we talked about. We're going to be putting that number here. Like whatever number just gets slugged, like kind of hit in the face with, that doesn't change. That's your starting number. And then there's going to be a rate of change, which is like a number that makes things go up and up and up and up. All right, so we're asking you to be pretty mathsy, but um, what we might find is that if we give you a situation, like if this situation was just said out loud to you and it wasn't maths class and you were asked to do something, you wouldn't have any problem actually just like doing the actual maths behind the scenes, right? So if you and your four best friends were buying tickets to a concert, right? So I put this picture here just to show that that means there's 5 people, right? In case you missed that concept that you've got 4 best friends and yourself, that's 5 of you. You're all going to a concert and you need tickets, right? That means you need 5 tickets. So Ticketek has the tickets. They're on sale. They're $70. Pretty cheap for a concert these days, but they're $70 each. And Ticketek being the way they are, they're going to charge you $5 to print them off yourself, right? $5 is a charge to just go to their website and buy them, right? And then the question is like, how much money do you need to buy your 5 tickets from Ticketek? And like already you guys are probably thinking, well, that's pretty easy, right? I know my tickets are $70, right? I need 5 of them, right? So it's 70 times 5. Right. And then what we're going to have to do at the end is we're going to get charged $5. So we better add that on as well, right? It's just $5, not per person, but overall, right? So we put that in, we get to $355. All right, what you've actually just done there in that real life situation with real things is you've done a linear equation, right? This is your gradient because every time a new person decides to come to the concert, it's $70 more, right? So your cost goes up and up and up and up by 70, right? If it was just you, it'd be $70 for you. You know, another friend is 70 more. That's a gradient that keeps happening. But this $5, we call that our constant because it happens no matter what, right? Whether there's 1, 2, 3, 4, or 50 of you going to the concert, you get hit with $5 up front. All right, so if we're applying your instructions to this question, what are your variables? What are the two things you're measuring? You are measuring how many dollars you are being charged, right? The dollars will equal something. That's after you buy some tickets. All right, so what I've done is I've replaced the letter Y with the dollars because that's what we're solving for. And the letter X is the other thing we're working with, right? But that's our tickets, right? So we'd like you to try and not use Y and X, but to use the real life things. But if you do get stuck, you can use Y there and X there. And then whatever number goes here is your rate of change, how much it goes up by. And this goes up by 70 at a time, right? $70 per ticket, right? Pretty straightforward. And then we're going to have, in every question, a starting amount, right? That we get charged no matter what. In this case, we're getting charged $5, so we add that on the back. All right, now we have a rule for any amount of tickets, right? I can put in 0 tickets and still get charged $5 because Ticketek would do that. If I put in 1, $70 for a ticket plus 5 is 75. If I put in 2, that's $140 for the tickets plus 5, right? I've made a linear rule out of a real life equation. And if you can just kind of think about common sense about what's actually happening in the question, it might help you build this, right? Because all you got to do today is really build these equations so you can then use them. You can stop watching now if you want and go and do your work, but we're actually just going to do the first couple together just to get everyone started on the right foot. If you feel confident enough to go and do them yourself, you can, but otherwise you can get your sheet out, print it off, play along. So this question here, we've got the Green Cab Taxi Company. They charge a $3.60 flag fare. You guys might not be familiar with taxis. We don't have that many in this region. I don't know if Uber's here yet, but soon they'll put the taxis out of business. This $3.60 happens the second you get into the taxi, no matter what. That's what a flag fare is. It's the fee they charge us for pulling up. Then we've got this $1.50 per kilometer, right? So that means it's going to happen for the first and the second and the third. It's going to keep happening over and over and over again. So we should be identifying this as our steady rate of change as our gradient. All you have to do, right, for part A is, it doesn't say it on the question, but you've got to make the equation out of it, right? So the equation is here to solve how many dollars your taxi ride costs, all right? And then the next thing, right, is our steady rate of change, right? We have to put the number there that keeps going up and up and up and up. So because I know that has to go there, you should just put the $1.50 right there. And then that $1.50 happens for every K, for every kilometer. I'll use K for kilometer. And then the thing that goes last is we're adding the amount that we start with. And we start our taxi ride by being charged $3.60. All right, we've done part A. We've made the equation. That's the most important part of today. So they're all going to look like this. There's going to be a letter or a symbol here, a letter or a symbol there, a number that keeps going up and up and up here, and then the other number goes there. For part B, we're going to ask you to just do a simple calculation. If we take a 20-kilometer trip with the taxi company, how much will it cost? So for part B, right, this was A. For part B, all we want to do is we want to know how many dollars, right, try and show you're working out, if we go 20 Ks, right? So I'm putting the number 20 where K was, right? It's 20 kilometers, and it's as simple as going $1.50 20 times, right? They're being times together, plus $3.60. That means my dollars, right? You get your calculator out, and it's $33.60. All right. Everyone needs to have a go at all the part A's and all the part B's, or all the first two questions from each one. C is going to be a bit trickier, but it's not doing anything that you guys haven't done in class before. All right, it requires you to work backwards. Year 9s should be up to doing it, but if you find this part too hard, focus on getting these two right at the very least. So for part C, they're asking us a different question. How far can we travel if we have $12? That actually means they're giving us a preset amount of money, of dollars, right? So I'm putting it where my dollars is, and I need to just work backwards and solve it like I would an equation. All right, so this is just linear equation solving. It's working backwards. It's doing the opposite. You guys have had plenty of practice of that this term, right? But the two steps are going to be the same, right? So if you can follow along with these first two examples, you'll be able to do the rest just fine. The two steps are always going to be get rid of this number first. Right, show all my working out because it's nice to be organized. But you know, we take the $3.60 from both sides. That gets us down to this. Right, we like to write down what we've got once we've got rid of something. Right, we see a plus we usually take, we do the opposite to get it to the other side. And then this is what we're trying to solve for. For Ks, we want to know how many Ks, and K being the thing we're solving is being times by 1.5, $1.50. So we should be dividing it away, right? Dividing the $1.50 from both sides. All right, that crosses that out. So it's going to give us the answer now. If I go $8.40 divided by $1.50, it's going to be 5 and a bit. It is. I think it's going to end up being about 5.6 kilometers. You can check that on a calculator, but that's basically the idea, right? You're going to take away that number at the back and divide by the other one, and then we've answered part A and B and C. And look, you're partway through your worksheet for the day. This is the last one we'll do together. Play along if you want, and then you can go and do the rest of it yourself. So we've got a car rental company, so pretty similar to before, to the taxi. They charge us $50 for renting their car, plus we have to pay $1 per kilometer. All right, so this dollar thing, you should be thinking this dollar thing is going to happen a lot of times, right? Again and again and again. That makes it my gradient. This $50 is a flat rate. It happens once at the start, right? Thinking about what happens with those numbers will just tell you where to put them. So again, with this question, part A, we're solving dollars, right? It's a dollar equation. It tells us how much to pay the company. And then the rate at which we get charged is 1, right? It's $1. And it's $1 again per kilometer. All right, so if I go 50 kilometers, you know, that's $50 there. If I go 75 kilometers, that's $75 there. But no matter how many kilometers I go, I get charged the 50 at the start, no matter what. All right, so I have to add that on to whatever distance I go. That's my rule, right? That's just what we're asking you to do, right? Put the right number here and the right number there, right? If you're guessing where they go, at least you're a 50% chance to get it right, yeah? And then these letters, you can call them whatever you want. I use dollars for dollars and K for kilometers. So part B is always going to ask us to put something in here, right? We want to know how many dollars to pay, how much it costs if I travel 50 Ks. All right, so it's 1 times 50, $50 for the kilometers plus $50 no matter what. So ends up being $100. All right. Again, this is the minimum that everyone should be doing for each question. I don't think there's any reason why people shouldn't be trying the part C of each question though, because you guys know how to solve equations and the two steps are always the same. Right, this time we've got to put the $210 at the front. They're asking us how far can I travel with 210 bucks? Right, with my rule being $1 per kilometer plus 50. So your two steps are to take away $50. And in this case, we'd normally have to divide by this number here, but this number is 1, and dividing by 1 doesn't do anything, right? It's $1 per kilometer, and I've got to the number 160. So the answer is that I can go 160 kilometers before my money runs out, right? Those are the first two done for you. The rest of them all follow a very similar pattern, so we can get you guys really familiar with it. Right, the main skill is getting all this set up, putting everything in the right spot. Then we're just going to ask you to put a number here and a number here.